Morning.
Morning.
Hello.
Hi.
Wow.
That's great. Welcome. We've got a few more people than we usually do, so. Yeah, it sounds like Amanda will be here shortly, and Jesse is actually at AAAI in Washington, D.C., and he may or may not be here right away. I don't know. But, what we do usually, I see we have some new people, is that we have updates. But first, I wanted to give the new people a chance to introduce themselves if they would like. So you can unmute yourself or you can type in the chat.
Am I audible?
Yes.
Okay, so hi everyone. I am Rajagopalan. I'm currently a second year CSE student and I'm from Amrita University, India. I recently joined the Slack channel like 1-2 days ago and I found few projects interesting, so I thought I can join the meeting and gain further insight. Yeah, that's it from my side.
Oh, nice to meet you. So yeah, and we'll be talking about the GSOC projects a little bit later. Vrushali? Okay. I don't know if she's there right now, but I'll give her a chance to get. Why don't we go to updates first, and then she can introduce herself after. And so, Brian, how are you?
I'm doing pretty well. Vrushali was here earlier, and I think that they were typing in the chat. So Vrushali, if you're there, just feel free to type, and we'll jump on you. Hi.
Hi.
Yeah. Hey. Let's see, updates. Yeah, for me, I've been just working. I haven't been able to spend as much time cleaning up the GSOC stuff as I'd like. But in a way, I'm kind of happy about that. I think I'm excited about people getting involved and bringing their own visions about it and what it can be and what it can do to the table. I think that's really, this project is about original ideas about how to implement ethical auditing tools using techniques of artificial intelligence and other things. So I'm really excited to hear what other people are thinking and what they're excited about with regard to that project. So I'm looking forward to talking about it later. But I have no concrete updates on it myself because I've been working on a lot of other things, including a presentation that I'm able to give today, but don't have to.
Oh, wow.
So yeah, I think we talked about it a little bit last meeting or on the Slack. And I think Jesse was like, well, do you want to give a presentation on this book you've been reading? And sure. So I'm prepared to do so if that's fun. If not, I love putting together presentations, so always happy to do that.
Oh yeah, I definitely want to see it. We'll finish up updates and then we can do that.
Yeah, of course. Yeah, that'd be great. So and trying to think if there's any more updates. Not so far. Oh well, so last weekend I attended was it last weekend or 2 weekends ago? Sometime in the last month. I attended the Limina conference on UAP studies.
Yeah.
So we don't talk about that much in this group because we're focused on other things, but it was very fascinating. Especially the development of a philosophical methodology with regard to unexplained aerial phenomena was super interesting. So if anybody ever wants to talk about it, it's just emerging as a field and it's very fascinating.
Yeah. Well, that sounds great. Yeah. So we'll come back to the presentation and yeah. So it looks like Amanda's here. Hello. And Hussain. Did Hussain want to give an update?
Hi. All right, so for those of you who are new, nice to meet you. My name's Hussain. excuse me, I'm actually right now a grad student at the University of Toronto, but I've been doing some work in the lab since last summer, and I plan on continuing with Google Summer of Code 2023. So yeah, like recently, about a month ago, I submitted a manuscript, a philosophy manuscript, which still waiting to hear back from, and that was actually a manuscript about scientific realism as it relates to virtual worlds and virtual reality. In my spare time, I've also been spending quite a bit of work getting familiar with Unity and Blender to try to get ready for like this next summer. But they're basically things that I'm learning how to do just for my own sake. Unity and Blender are both 3D. They're both excuse me. They're both 3D software. Unity is mostly used for game design, game development, and programming and stuff like that. And Blender is used for animation and artwork. And there are a lot of really, really neat and cool applications in science and scientific research that you can use with both of them. So yeah, that's basically where I'm at right now.
Yeah, you were showing off some of your. Oh. Yeah, you were showing off some of your work in the Slack. Some of your animations that you're trying out. Yeah, it looks pretty good.
Yeah, thanks.
Yeah. Yeah, I look forward to talking about that more, in the future meetings and that. So keep up the good work. Like I said,
yeah, I'm not sure if I...
Oh, go ahead.
Sorry, what? Yeah, not sure if I mentioned this to you, but I was actually surprised. I was actually surprised that so for Google Summer of Code 2023, one of the project ideas for under DevoWorm is to create some sort of project using Unity and/or Blender, as far as open source software could be used or could be useful or beneficial. Like for one example, it could be recreating the Morris water maze experiment using Blender. Just creating an entire like tub or 3D like area or pool of water and creating some sort of experimental platform or a place where people could actually test that out in the virtual environments. I was actually surprised Blender is being used. From my experience and who I've been talking to and who I've been working with, a lot of studios, at least in animation and game design and development, are using Maya instead. Bradley, I'm not sure if you've heard of Maya, you're familiar with Maya, but it's basically like Blender's. It's another 3D software animation, 3D animation software that people use in addition to Blender. So, yeah.
Yeah, we talked about that. Yeah, it was I think the thing is that you need a site license to develop on that, whereas Blender and I think Unity you don't necessarily need that. But there are trade-offs always with things like that, and the thing I was thinking about for this GSOC project, and I'll get into a bit later, is to create these 3D objects, but also to be able to put them into like a virtual environment, or at least navigate them in a headset. So, you could go inside of a object or inside of a space, and, there's a lot of, cognitive science related to like spatial navigation and, being able to navigate through like models and data that you can get insights that you couldn't get otherwise. So like if I had a point cloud even, and I put it in a 3-dimensional visualization, I could walk through the point cloud or, kind of explore it from different angles. And it's, we don't think about the cognitive psychology that much, but it does have like some sort of, Cognition in the Wild it's a book that they talk about some of that. So, thank you, Hussain. That's great. We can keep talking about that. We'll talk about the GSOC projects a little later, like I said.
Okay, thanks.
Yeah, all right. Amanda.
Good morning.
Hi.
I don't really have any updates. Cognition Futures has been going well. Methodologies project has been moving forward. I haven't looked at the annotated bibliography spreadsheet since our last meeting, but that's growing. That's good. I have a lot of papers on my to-do list that are relevant to that I will submit entries for. maybe this next week we'll finish Fuchs. I don't know how long this last chapter is, but we're on the final chapter, I think.
Yeah.
For our reading group. And then it's still open what we'll be reading next. So if any of the new members want to like become familiar with what the Cognition Futures group is, and then maybe share your thoughts on what would be useful to read next. Either, so we're gonna pick a book, but then we've also been collecting papers, which is the annotated bibliography that I mentioned. I think that's it for me. Brian, I would love to hear your presentation. I forget what the book is, but I remember last week thinking that it sounded very interesting.
For the benefit of go ahead.
I was just going to say it's definitely related to our cognitive futures stuff. And I was sorry to miss the meeting on Wednesday. I completely lost track of time. But I'm so excited about this. It's coming together. Yes.
That's great. For the benefit of the new people, Amanda, could you describe Cognition Futures a little bit, or what we're trying to do in our reading groups?
Yeah, we're basically, so it seems like it was inspired, and this is, maybe Jesse could say more if he joins, but it seems like it was inspired by cognitive science seeming to be at this weird, I don't want to say standstill, but it seems like cognitive science as a discipline has broken off into all of its factions, and there's progress being made in all of these disciplines. But what's lacking is a kind of unity and a kind of common language in some cases in cognitive science. So we have read 2 books. We're on our second book, and the first was focusing on developing like a methodology that centers the first personal experience of the world, primarily like our first personal our subjectivity, and how you could possibly incorporate that in more formal studies of the mind. And then this second book, so the first one was On Becoming Aware by Varela DePraz and Vermersch.
Yeah,
Varela is the big name, Francisco Varela. And then the second book is by Thomas Fuchs. It's called The Ecology of the Brain. And he also takes this like first person as primary perspective, but he is trying to offer like a more formal theory of mind, more scientific, though very, very philosophical as well, very informed by like phenomenology. So yeah, we're looking at work that tries to unify the studies of the mind, and that's very broad. But one main theme so far that I think is important to all the members of the group is that it centers like the first personal phenomenology in some sense. Because seems like one of the causes of this disarray in cognitive science is you can say XYZ about the brain and about, neurons. You can describe things at the systems level, which is better, but it often neglects just what it's like to be a person. So how can a rigorous study of the mind incorporate what we know from being minds? So very open. And there's definitely a lot of room for like spin-off projects. So this methodologies project I mentioned is we're making an annotated bibliography of various attempts to study the mind using like various methodologies. So like systems neuroscience, pure like phenomenology and philosophy, evolutionary biology. And so we're collecting these resources with the goal of maybe finding like a common language and articulating how these different perspectives could possibly interact with each other in a way that is fruitful.
Yeah, that's a pretty good description of it. Thank you. I've been doing a lot of reading, a lot of discussing. The whole point of it is to get like a discussion going and to start to pull on things and see where they fit together. We've been doing a lot of, our next phase of the project is sort of making like articles and presentations where we take everything we've been discussing and kind of bring it into some sort of deliverables. So we have, we haven't really gotten anything out yet, but we're kind of working on. That's why we're doing this bibliography, for example. We're trying to put together a set of resources in a formal way, and we can have them all, put together. Okay. Yeah, so the thing about the group is, and I don't know where Vrushali is, but it's at 8:30 in North America, like in Eastern time zone. So I don't know if you are in India or Europe or wherever, or the US, but that's something to keep in mind. But yeah, it's not, we usually try to do, like I've tried to do morning meetings in the past to sort of make it maximally accessible. But that's in this case, it's just kind of one of these things that we have to do in the evenings. So we do record them. So if you want to check out the recordings, you can do that.
And there is the opportunity for like asynchronous work on the projects. Maybe not so much the book discussion, but definitely on the annotated bibliography.
Yeah. All right. Vrushali, did you want to give a short introduction about yourself, what you're interested in? You can do it in the chat or by voice. Okay. I don't know if you're still there or if you want to do, but yeah, we can do that. And, you can put it in the chat. So I was going to turn to Brian if he wants to give his presentation. I was kind of waiting for Jesse, but I don't know if when he's gonna make it. So
Yeah, and Jesse usually records the meetings too, right?
Oh no, I do.
Oh,
Yeah.
Great. Thank you.
Yeah.
Sorry, my mistake. Great. Then in that case, I'll give it so that way if because I know he's the one who asked me to do this, so yeah.
Right.
But yeah, here we go. Let's see if I can give it. I think I can do it without sharing my screen, but I'm not sure if that's a good thing, actually. So let me just figure out the best way to do this. Do. Okay, here's my screen.
Yep.
And here's my presentation. Can you all see it?
Yes.
Oh, great. How do I present? Okay, there we go. Is this working still? I just have to make sure.
Yeah.
Okay, great. Because I think the first presentation I gave in the lab, I got cut off and
Right.
I don't even know what happened.
Oh, that was a crazy glitch in the.
Yeah, there was some weird thing. In fact, with that in mind, I'm just going to keep my Jitsi open on my other monitor just so that I can monitor that everything is working. Okay, great. Oh, and Vrushali actually just wrote something in the chat to introduce themselves. So let's look at that first.
So hello, I'm Vrushali, first-year student at IITM India. That's a technical school in India. I'm passionate about computational neuroscience, data science, and AI stuff. I'm enjoying a lot for this meet. Thank you. Yes. So for Vrushali, we do a lot of interesting things with computational neuroscience and philosophy and cognitive science, and then of course the technical side of things. So you're welcome to join our meetings, and you're welcome to participate in anything you want. And channel, you can go through the Slack channels, and then if you find something interesting, let us know. You can just drop a note in the channel. And this goes for you too, Raj. You can drop any notes in the channel, you can join our meetings. Like I said, a lot of the meetings are in the morning, but the Cognition Futures is in the evening in North America. I'm based in North America, and some of our other people are based there as well. But we try to be accessible to the rest of the world. So, we do a lot of asynchronous collaboration. So that's the norm for us. So don't feel intimidated by that. We try to facilitate that whenever we can. So.
Yeah, and as somebody, I just did the summer school. I think IIT was actually part of it in, oh God, why can't I remember the name of the summer school? It was on computational modeling and AI techniques of like few shot learning and everything. And it was really wonderful. I got to experience being on that side of another time zone firsthand. And that was really, really made these problems palpable. So I really appreciate you saying that, Bradley, because I often forget. So great. And yeah, I second everything, obviously, Bradley's saying.
Yeah.
So I'm going to try to explain something that is really difficult to explain. And not only is it difficult to explain, but it's from 1996, which, usually we try to focus on the most current things. But I think it's useful to look back every once in a while and see kind of what came before. And I think in this case, this book in particular came before Wolfram's A New Kind of Science, before object-oriented ontology, the philosophical movement, and speculative realism. Some might argue, maybe that's a little debatable, but before a lot of things that now seem totally obvious. However, it did come after the embodied mind, so there's a little bit of natural neurophenomenological aspects to his arguments. But I think it's worth looking into for these reasons, that it's a foundationalist argument that kind of set the stage for a lot of future things. So I'll try to, I'll just read what's here. That I found this book wonderfully written, super exciting. And when things are exciting, for me, usually I read a little bit and then I have to put the book down because I'm just, thinking. So that said, I've only made it through the first half, which is analysis. So I haven't even gotten to the construction part where he actually puts together his proposal for a metaphysics or a foundation for how to think about computation. And he also says at many points that after many, many attempted lectures, he's found that it's impossible to describe his ideas in an hour accurately, which will become clear very quickly, I hope, through this presentation. So I'll do my best, but I'm only going to focus on analysis. But first, what is this book about? So it all starts with this idea of a cut between computation and intentionality. This idea that how do we communicate to our computational instruments, to our computers, to our machines, what it is that they're looking at. And there's an example of this is coming, but I'll just put that idea out there first. That's the first cut. It's a foundationalist project attempting to formulate a foundation account of computation that's going to be usable by computer scientists and mathematicians that are working in the real world. That's a lot of focus on common sense things. And I love his two criteria. I think this is an interesting set of criteria, especially in regards to the methodological work that we're trying to do in cognition futures. His two criteria are that the theory must be empirical in that it must be able to explain how Microsoft Word works in some explicit way. So that's just an example. So like his example is from 1996, Microsoft Word was what everyone was using. Now we might say the theory must be able to explain how Google works or how, how, I don't know, whatever, you get it. Then the second one is a conceptual criteria, that the theory must be able to explain or account for cognitivism or cognitive science as a whole. Just that whole idea must be part of this. It must be able to be explained by whatever this theory ends up being. And yeah, it's a work of computer science, even though it seems like it's a work of philosophy. It's interesting. So the first part that I'm going to go over today is just analysis. And this is broken down into 5 sections, which I'll go over in detail, though not entirely in detail, but enough detail so you get the gist of it, of each one. And this diagram that we see here, process versus program semantics, is at the core of this analysis chapter. So most people, when they think about writing a computer program, don't tend to acknowledge this process cloud over here. That process cloud, between the program and the subject matter, there's actually 2 kind of streams that it's useful to differentiate. And stream alpha from program to process is one. And that's just, how do we decide what process to make the machine engage in? And then beta, the other move, how do we talk about that process in relationship to the subject matter that we are actually writing the program for? So we'll get into a specific example of that, which is over here on the right, a Coke can collecting robot. Now I'm just going to focus on this diagram really quick for a second, and then I'll talk about the text. So this Coke can collecting robot, its subject matter is the X and Y coordinates of itself in relationship to the Coke can. That can be written about in many different ways. So the process by which it approaches the Coke can be, for example, egocentric. So it could be about where the robot itself is. Is the XY coordinate of its relationship to the Coke can about, I'm this many X coordinates away, X points away, I'm this many Y points away? Is it in a 3-dimensional objective space? So not an egocentric reading, but an objective reading, I understand myself to be in this room. I am this many points away from the center of the room, this many points, etc. And there are many other ways you can think about this. So it's an example of elucidating this last diagram of the difference between why process is important and why you can't just go from a program to a subject matter. You have to decide intentionally, going back one more, you have to decide intentionally what your computation is and how you're going to make it work. And that should line up with the form of what you're trying to do in this relationship to subject matter. And why? Other than just that it's interesting and useful. Well, one good reason that Cantwell-Smith gives is inscription error, which is defined as a tendency for a theorist or observer first to write or project or impose or inscribe a set of ontological assumptions onto a computational system, and then to read those assumptions or their consequences back off the system as if that constitutes an independent empirical discovery or theoretical result. So in this case, say we conceive of this robot as being egocentric. And then if we make an inscription error there, we've decided our process is egocentric. The can is only conceived of in relationship to the robot itself and not into some third party or objective space. Then when we look at that robot through the lens of that process, it's going to be clear to us that the robot is obviously interacting with that can in relationship to itself. And so that would be an inscription error, because the only reason we see that so clearly is because we decided that that was our process in the first place. So it's this kind of weird feedback loop that is so common in computer science. I think, especially in AI, I think this problem has only increased as time has gone on. So this is another very good example. And it's an example of how to avoid inscription error, like ways of thinking to kind of get your brain past this tendency to just inscribe without considering. So in each of these pictures, there are 3 robots. The one on the left, each robot is programmed to just say me. As it moves through time, in this case, you can see the bracket on top of it, it's saying me. And so when we bracket these robots off, we're using time as a bracket, and this makes that more clear here. So you can see those brackets. Here, and I'll use my my mouse. These brackets here are crossing across time because they're talking about the meanness of the robot, the individuality of the robot. The robot is talking about itself. Whereas if it's focused on nowness, then you have a space spanning reference. So these are this is an example of an alternative to inscription error, or a way to start thinking to avoid inscription errors. He goes on to make a second cut then, based on this idea of inscription error. One way to avoid it would be to to rest computation on top of intentionality and ontology, because intentionality itself is not enough. That's how you end up with these inscription errors in the first place. And in order to explain intentionality and ontology, you need a metaphysics. And part of that is what he says here, that the most important and difficult task facing the cognitive sciences is that it must be impossible to have determinate representational content for there to be a fact of the matter as to how the world is represented, without that analysis depending on any way of taking the internal structures in the mind that does the analysis. So this is kind of a convoluted sentence, but basically he ends up from this sentence with the third cut here at the bottom, which removes computation from the equation entirely, because computation, resting as it does on metaphysical concerns, resting as it does on metaphysical concerns, without answering these metaphysical concerns, we can't really talk about computation. And furthermore, computation isn't even really a thing. It's not a subject matter. There is no way to proceed on the overall project, that is, of developing a comprehensive theory of computation which meets Cantwell-Smith's criteria of being able to explain Microsoft Word and being able to account for cognitive science itself, cognitivism, except by taking on metaphysics and ontology directly. So, and then I really like this other one, this quote down here at the bottom, where he says, there will never be a satisfying and intellectually productive theory of computation of the sort I initially set out to find. So this is in relationship to a project that he explained he embarked on decades before to try to make a reflexive metaphysics of computation itself. And from doing that, he found out a theory of computation will not supply a theory of semantics, as Newell has suggested, nor will it replace a theory of semantics, nor will it depend on or rest on a theory of semantics. It will do none of these things because there will be no theory of computation at all. And I love this. He's like, it's so great. So computation is the point. Computation is what he's dealing with, but in order to deal with it, he can't talk about computation at all. So he takes an idea from the philosopher of science, Bruno Latour. By the way, if anyone wants to talk about these ideas, there's a lot here. So feel free to speak up and say, that doesn't make any sense. What are you talking about? I would love to talk to people about this. I think it's fascinating. So if anyone knows who Bruno Latour is, you might be familiar with Latour's concept of irreduction, which is eerily prescient with regard to Wolfram's principle of computational irreducibility that came out just a few years after this book. So I think there's a lot of overlap here with Wolfram's ideas. But Bruno Latour, and at least in the 90s, defines irreduction as nothing is by itself either reducible or irreducible to anything else. So that's, it's such like a continental, like French approach to this topic. So Cantwell-Smith takes it and uses a commercial metaphor for the concepts, for how to talk about irreducibility in relationship to the concepts he's coming up with, and claims that in order to be irreducible, you must be prepared to say where you bought it. So like, who are you getting this idea from? Where's it from? Like, what's his historical context? What's its place? Like, what do you perceive it as? How much you paid for it? So like, what do you have to give up in order to accept this idea? What are your assumptions about the world? What are your philosophical definitions of all the words you're using and everything else? And then finally, how you got that concept into your current theory. And this for him is the answer to irreduction. and to how to implement it in a concrete way. So, because this is a foundationalist project, it's easy to assume that it can't be irreductionist. That in order to constitute a foundation, like Descartes or something, to say the mind-body problem, to say, I think therefore I am, that you must reduce in order to look at foundations. And if you're not reducing, then you're constructing an alternative ideology. I don't know about this one. I think it's a really interesting phrase, and I'll talk more about Smith's kind of constant attempt to get out from underneath politics, to get out from underneath semantics. I think there's a lot of wishful thinking at work here.
Yeah.
but 1996. All right, so we've been through 2 chapters already, believe it or not. We've done computation, we've done irreductionism, we've got 3 more to go. The next one is realism. So what Cantwell-Smith proposes is a successor metaphysics, a metaphysics that kind of holds space for all of these other subjects to exist within. And he claims that the reason for, or the method by which we can arrive at this successor metaphysics is through realism. And by realism, he doesn't mean this diagram down here. So there are at least 2 untenable readings of the word realism that he's trying specifically to avoid. And one of them is, world independent of the experiencing subject. Relation to its subject is independent of the subject, and its form of separation is logical, versus the characterization of that there is an external world. If the tree falls in the forest, its relationship to the subject is external, and its form of separation is physical. Like maybe you're a few feet from the tree, etc. Whereas if the world is independent of the experiencing subject, then the tree falls in the forest and you don't hear it, and it doesn't exist because logically it can't. It hasn't existed for you. Anyway, but he rejects both these reasons, both these definitions of realism, and instead focuses in on creating a new kind of metaphysics that is focused on what is metaphysics allowed to be, rather than assuming that metaphysics can be discovered or constrained in that way. And that comes from Harding in 1986, which is a fascinating book. So the metaphysics that we're looking at here, the successor metaphysics, is in contrast to modern and postmodern metaphysics. So he was making these cuts earlier between computation, intention, ontology, metaphysics. And this is more cuts on the left here to explain how the picture of modern metaphysics that we have kind of has a missing piece for the humanities. There's no solid foundation as such. And he characterizes, in 1996 again, the postmodern metaphysical project as being, well, if the humanities have no foundation, then nothing needs any foundation. And, everything's just flying around, which is super interesting and really great. And I think that the successor metaphysics is a viable alternative to both of these models, wherein the metaphysics provides an environment for disciplines to thrive rather than constraining them. Or even trying to ground them as such. So he also references Hilary Putnam's book from 1990 about a separation between the uppercase and the lowercase concepts. And he uses this a lot. And again, this is another dubious thing where he's trying to separate his arguments from historical context and politics. He doesn't say politics, but that's pretty obviously what he's saying. And so he uses a lot of lowercase and says, I would talk about realism with capital R, but no, I'm talking about realism with a tiny r. And he says why he's trying to do that is down here at the bottom. What is real with a capital R has become at the very least challenging to, and at worst outright incompatible with, what is real. So that gives you an idea of what this uppercase versus lowercase differentiation is doing. And I think he's trying to do this because he wants this to be a practically applicable method, a practically applicable theory for computation and for computer science. And so that's, I think, part of why it's useful to make these distinctions. Within his realism, there are 7 constraints of the realism's applications to subjects and objects. I could go through all these if somebody's interested, but mostly this is just here in case we wanted to dig down into what the realism is. So the 4th chapter is particularity as distinct from individuality. So when I say, and I love this example, when we say in English, it is raining, what do we mean? What is the it in that sentence? And how is the it in that sentence different from the rain is falling? The rain is not raining. The rain is already rain. And so the difference between those two things for Cantwell-Smith is individuality versus particularity. And so he wants to make this this distinction for many reasons, but mostly because when we make a computer program, if we try to explain to a computer program the difference between the weather condition or the weather, what is it called? I can't remember. It is raining. How do we explain to the computer? How do we get it to intentionally consider what rain is when we say that? When we say it is raining versus the rain is falling? It's difficult unless we separate individuality from particularity. It's difficult to do that semantic jousting, as it were. So finally, the end of analysis is a chapter called Physics with a small p. And these are the 3, I think, the most interesting parts of this whole chapter, which is to say that naturalism is realism's methodological correlate. So given this small r realism that he's proposing, we can use naturalism as such as a methodology for working within that realism. And if we move forward from that, we can say that physics and physical laws are related to naturalism. Like that's they're kind of the expression of naturalism, and as such, they're fundamentally deitic, which indicate like that they I don't really know if I can explain this very well. I mean, deism, is this idea of like creating like something as if it was a god, and I think that for him, the laws of lowercase physics kind of are proposing this kind of god, this like kind of explanation of the world. They're trying to explain it through some kind of deity. And maybe that deity is, the power of gravity, for example. Like, oh, that's gravity. It's the deity of gravity. Newton doesn't say that, but that's kind of what he means. So part of what he's trying to do by focusing on physics and naturalism is get us away from these inherently almost supernatural attitudes toward naturalism and towards physics. And he ends up at the end of this chapter with the criterion of ultimate concreteness, which again, so reminiscent of Wolfram's principle of universal computation, which I can't remember exactly. Anyway, and so the criterion of ultimate concreteness says no naturalistically palatable theory of intentionality, of mind, computation, semantics, ontology, objectivity, etc., can presume the identity or existence of any individual object whatsoever. So you don't assume that an object exists. You have to decide that the object exists in order to talk about it concretely. So to talk about some of these ideas in a little more detail, and then I'm almost done. Naturalism is realism's methodological correlate. I really like this diagram because it kind of shows you how we have physics on the one hand, and then a more common sense naturalism on the other. That's pretty much it. And then, so for Cantwell-Smith, he's not proposing that physics is the way forward, like is the way to conceive the world to explain it computationally. Like, no, it's a stepping stone on the way to the successor metaphysics, the new metaphysical ground. He talks a lot about participation. That in order to get intentionality into computation, the person doing the person or thing or thinking being must be participating in the philosophy of presence of an object, and that physics is a good stepping stone on the way there, because it has a sort of ontological application to our everyday lives, and in that sense, it's useful to connect computation with this new metaphysics. So he talks about the realms of physics as being useful to that. I just kind of like this drawing, honestly. I don't know if it's really useful to go into detail here on this one. But it is fascinating to me that in these realms, each one is populated by a different ontological type. So this is a good kind of framework or grounding for talking about the different ontological types of objects and just kind of seeing which one each one falls into. We're at the end. So conclusion. This book is basically an attempt at constructing a more common sense ontology useful to computer science. I'm just going to read his last paragraph because I think it really describes the project and the whole analysis aspect of it very well. So the divide that we've been talking about between subject and object, between sign and signified, is not the only dualism to be barred by the prohibition against prior or preemptive inscription, that inscription error we were talking about earlier. All sorts of other standard ones are included as well. Between mind and body, between nature and society, between concrete and abstract, yes, even among the three realms of physics we referenced in the last slide. But the mandate is by no means wholly negative. One important benefit of going in under these distinctions, his constant attempt to get out from under politics and semantics, is that it makes room for the account to recognize that objects are inexorably cultural, biological, political, psychological, social, evolutionary, historical, economic, and so on and so forth, i.e., are everything that social constructionism and critical studies have shown them to be, without, in the first Aboriginal instance, having to pay the price of these ineliminable, but nevertheless very expensive notions. And I really like this conclusion because he's being very concrete about saying, like, social construction is the thing. Critical theory is important. It's very expensive, but we can't just throw it out the window, especially if we're going to be irreductionist. Yeah, and that's it. And then he's going to go on to construct his theory, and maybe I'll talk about that next week or in a couple weeks if I can, depending on how fast I can read it.
That's very good. Thank you.
Thank you,
Brian. Yeah.
Yeah.
So, yeah, I wanted to move on to other things, but did we have any immediate comments, questions? I know that Amanda said it's very second order cybernetics. So
Yeah, I said that before the last slide. It's by the last slide, it's not just vibes, it's pretty explicit with the social constructionism line.
Yep, exactly. So there's a lot to talk about there.
Yeah.
Very cool, thank you.
Yeah, Jesse.
I'll just say it sounds great. I wasn't here to start, and I didn't get onto it, but I can see why you were so excited and kind of mentioning it for a while, Brian. So I'm glad that you shared it, and I want to go back and read the whole thing, and I'm sure I'll talk to you about it in the future. But sounds great.
Cool. Yeah, we'll dive deep later.
Yeah, that's great. Well, thank you. Yeah, I think that's great. There are a lot of themes there I see that are sort of compatible with the things that we're interested in, especially, the programming aspects, of course, thinking about programming. And if you go into the literature and computer science, deep diving into like the 80s and 90s and somewhat in the 2000s, people were really turned on by these sorts of ideas. If you look in the machine learning literature now, they don't really talk about them at all. But, you go back and people, I guess, still talk about them. I mean, we talked about Douglas Hofstadter's work, who's, of course, thought of as a cognitive scientist, but he got his degree at the University of Michigan in in complex systems or whatever that program was back then. But, it's like very much in that spirit. And so, yeah, I think that's something that we should talk more about, especially with respect to some of these ideas of physics and intentionality and linking, like a lot of the stuff we see as reductionist science with some of these experiential things and other types of, yeah, Vrushali says it was great. Looking forward to reading it. Thank you for sharing this. Yes, so we'll be, we will be coming back to some of these things, maybe later in the meeting, because I have some things that we're going to talk about.
I appreciate you making space for it. Thank you.
Oh yeah, no problem. So yeah, okay. Jesse asks, curious how it scores with the bitter lesson, which is of course the essay by Sutton. So yeah, I don't know. Yeah, Brian doesn't even.
We can talk about that in Slack. I know we got stuff to do, but I'll drop my questions in Slack basically and go from there.
Yeah,
it's a great question. I have to think about it.
Yeah. Okay, so we have I wanted to move on to the GSOC proposals or the projects that we have. And if you go into the Slack, I'm going to share my screen. If you go into the Slack, they're in one of the channels here. I think it's the GSOC channel where we have a list of projects. So there are 3 projects that we have. One is through DevoWorm, which is our working group on developmental biology and other things like that. And then we have another project 2 projects through this part of the lab, which is the open source sustainability, which Brian we worked on last summer, and Hussain worked a bit on it. He was one of the GSOC students. Brian actually had worked this into like a sustainability platform over the course of the last year or maybe 9 months. So we're building from that. And then we have the VR and 3-dimensional graphics project, which I will discuss. Let's see. If we go to I think there's a Google Summer of Code channel here. If you're not a member of this channel, I can make Vrushali and Raj members of this channel later. Or if you want to join the channel, I think you can just join. This has some of the information here on GSOC. So if you're interested in GSOC, you can join this. We'll be announcing things in this channel. We have our projects. So we work through, the way GSOC works is we go through an organization. Last year we applied as an organization, but we didn't get accepted. So this year I didn't bother applying as an organization. But we go through the INCF, which is the International Coordinating Facility for Neuroinformatics. And they do, we've been working through them for about 7 or 8 years now. And we've had different projects. What they do is they host their projects on Neurostars. So if you go to Neurostars, which is a platform, I don't know if I'm logged in, I'm not logged in, but this is a discourse instance for INCF. If you've used discourse, you know that you can chat with people on this, and this works in Markdown. So, you leave messages and you can organize your discussions. It's a very nice system. But we have this first project here, 4.2, is part of the INCF project list. Virtual reality for distributed research. And this is the one Hussain was talking about earlier. So this is basically the idea of this project is to build models for scientific applications or for visualizing data or whatever in that area. That's what we're interested in, building 3-dimensional models of those in some program like Blender or Unity, basically something that is open source and we don't need a site license for, because our lab is all about open source and accessibility, and then being able to build these models that we can then use in like a VR headset or build an interface on the web where we can display them. So that's the idea. And I wasn't specific on what's required here. There are a lot of options. You can build something like an experimental paradigm in psychology. So the Morris Water Maze is something they use in behavioral neuroscience, where they put mice in a pool of water and they have them find a platform. We can build a 3-dimensional virtual model of this and we can implement it for humans. So that's one option. Another option is to work with the OpenWorm browser, which is a platform that's been developed by the OpenWorm Foundation. It was actually developed by Christian Grove from Caltech. And this is about 10 years old, but it's still pretty good. It allows you to explore different aspects of the model organism C. elegans, which is a flatworm. And so normally you'd have to look under a microscope to see these worms. But here you can actually explore it using a three-dimensional model that's hosted on the web. And you can drop out layers, so you can look through the different layers of this worm. You can go from a solid body down to like the nervous system. You can look at the organs and the muscle and the cuticle, which is the covering, skin covering. You have all these different layers that you can look at this organism. And you can actually explore it cell by cell in this case, because we know what the cells, every cell in the C. elegans is. So this is something that, it's another option for looking at these things. So that's that project. And I'm open about like how people want to be involved in that. Then there's the open source sustainability project, which is 4.1. This is I think the last one was a half time or 175 hours. This one's 350 hours. This is the 350 hours is what they call the full project through GSOC. So it's like you can, it's basically 40 hours a week for the entire summer, or I think you can extend it into the fall. I'm not really sure how they're doing it this year. But in any case, this project is about maintaining an open source sustainability project. So like I said, Brian and Hussain last year were involved in this project where we had a problem. And that problem was, how do you maintain open source participation or participation in open source projects? As you may or may not know, many open source projects fail, just due to lack of interest or lack of sort of keeping things going. That OpenWorm browser I showed you was an open source project. That was made, and then it's been maintained, but in a very spotty fashion, because we simply don't have the people, the expertise, the eyes on it, continually. So people have been working on updating it from 10 years ago, of course, and that's something that needs to be done in all organizations. You also need to build new things, but you need to maintain old things. And so this project was a way to sort of get at some of these issues of sustainability. Now the project itself is actually working from the resources that we built on last summer. And in particular, this sustainability auditing tool, which Brian and a group of people from the University at Albany in New York State, they worked on a project last year or last fall to build this auditing tool that people can come to. They may have an open source community, they have a repository they want to evaluate or a project, they can plug it in and they can get statistics for it, but they can also run simulations, agent-based simulations, to tell people, maybe how to manage their resources better. And we had a number of models to come out of that work last summer. We also have a reinforcement learning model. We have an active inference model, and so forth. And so we have a bunch of different models for sort of modeling those communities and keeping them, they'll tell you different things about the sustainability of a community. So this project is just maintaining a lot of that. You'll have to go through the project and be right into it, and then figure out what you want to contribute and in your proposal. So there are a lot of different things you can do. You can do web development for the interface for this sustainability auditing tool. If you go through, you see that it interfaces with GitHub. And then I don't want to go through it right now, but you get a agent-based model that pops up, and you can run multiple models, and you can collect the statistics, and it's a nice interactive tool. So you can work on that, or you can work on improving the models, or you can work on any number of areas depending on your expertise. And then the third project is through DevoWorm. This is the graph neural networks for development. This is something that this is a full-time project, 350 hours, but This is a little bit advanced. This is what they call one of the advanced projects. Again, this was from last summer. We developed a graph neural networks pipeline to basically take microscopy images, segment them, take a time series of microscopy images. They often collect movies of developing embryo, and then segmenting that all out and capturing the action in that video, and then analyzing it according to building a graph of the embryo, and then comparing graphs across time, and then you can build these embeddings that describe the data. So this is something that, again, the basic framework has been worked out for this, but there's a lot that needs to be done in terms of development, in terms of maintenance, in terms of working out some of the things we didn't get to last summer. So this is really, if you're into like PyTorch or some of the other platforms for deep learning, because we're building upon a previous deep learning platform, but we're also building in the graph neural network capabilities. So this is something, if you're interested in that area, it's quite involved though. I would, I recommend that you, if you're really good at that, that's a good project. Otherwise, the other two are good projects as well. So that's our Google Summer of Code offerings for this year. Any questions about that? All right. Well, thanks to Ryan for the open source sustainability stuff and the talk, and we'll follow up on that. And yeah, so I know Jesse has been attending AAAI, which is a conference in Washington, D.C. It's on artificial intelligence. He's been posting some things in the Slack channel on that. We'll get to that in a little bit. What else did I want to talk about here? Okay, I did want to talk about some other things that we have coming up. We have some conference activity, some submissions that we're working on. So we have the submissions document. It's kind of not very high tech for what I show in the meeting, but this is basically laying out some of the things that we conferences we attend and some of the submissions and deadlines that we have. So we have the EI workshop, which is the Embodied Intelligence Workshop. This has been going on since 2021. It's a virtual event, and it really focuses on like embodied intelligence, which is computational agents, robotics, embodied cognition. There are a lot of different things that they do in that conference, and we've been participating in the last few years. What we want to do for this is we want to come up with some submissions for, I think they're going to be talks. They don't need to have a paper associated with them, but they do need to be like 20-minute talks or something like that. So what we need to do is we need to come up with an abstract for these. And I just got notification. I know Jesse saw that and he was excited. This is a couple days ago, so we need to do this in the next few weeks, come up with some abstracts for this and submit them. I have an idea for one abstract I'm going to submit personally, but I know Jesse is interested in submitting one through, well, we had it marked on, I think in 2022, we talked about this. We've been waiting for this event for a while. So this is the EI workshop here. I don't know if we have anything, I know Jesse wanted to do something on the Cognition Futures project.
Well, I could see that being, camera for a little bit here. I could see that being a variety of things. The great thing for those who don't know about the workshop is that it's one of the most, I think it's probably the most centered on like embodiment and embodied intelligence conference that is happening. And that's a difficult interdisciplinary view or lens to have. So it's kind of, the barriers to entry are fairly low, and it's a little bit of an obscure event. but what's great is like you have people from like robotics. There's a like adjacent event in soft robotics that they're doing in Singapore for the main event. But there's like robotics, there's philosophy, there's cognitive science, there's some psychology people. There's a whole lot of different things in there. So we could do a lot of stuff in that capacity. Here for a second. Well, so yeah, but I mean, like definitely something about the like the methods project will be easy to do there. But there's a lot of specific discrete things we could just run into a presentation depending on how much people want to talk about them. So it really depends on what people want to do, but there's quite a few things we could present there depending on how many submissions we want to have, basically.
Yeah. I think it's a situation where we have like one person, one submission, but like we've done this previously for the Neuromatch conference, where each person who registers can submit their own abstract. We do that strategically. So this is something we can do. We can figure out. I like I said, I want to do like one on something we're working on with critical periods, and then an embodiment, and then we can maybe work on one with cognition futures as a group, like what the group is up to. Or I mean, I might like to focus on a question more for that, but like I think the overview is good. But what is our perspective on it?
Oh yeah, I would suggest. I think that'd be a great place to get methodological feedback, like specifically, as in like we could come with a lot of questions about methodologies and sort of like something that, strategically speaking, a presentation that prompted people to give feedback about their methods for studying their realm of expertise would be pretty valuable. That may be a little more fine-tuned than some of the other stuff, but we'll see. We have some time to sort that out.
Yeah.
This is pretty slow. So
Yeah.
I'm gonna just turn this off.
Okay. So the other two things then, immediate that we're working on. Well, we just submitted to CogSci 22. That was February 1. That was an abstract that was submitted. I'm not sure I can't remember what the title of it was, what we ended up saying, but what was it on anyways? Jesse knows this.
I think it was related to the methods project. I think that was the one that was like continuing Varela's quest. So it was basically methods plus the kind of the classic take on the question of has cognitive science embraced methodology or has embraced embodiment.
Right.
So it's kind of in the spirit of that critique of that started off the reading group last time, which was several months ago, which was the that one. I can pull up the abstract here in a second.
Okay.
If you want to see it. Oops. Apparently it's not where I thought it was.
I can share my screen for
a minute. It's fine. I can't.
Okay.
It's not in the location I thought it was, but
Okay.
basically it's what I said. It's methods project related, and it's kind of Varela plus methods project plus embodiment.
Okay. So yeah, that's being evaluated. I guess I can change the color here. I usually put like the colors here. If it's like kind of like this color here, it's under submission. If it's green, it's been presented or it's been accepted. And then if it's red over here, it means it's coming due. So this is kind of the ideal. It doesn't always come out that way, but I keep this. I can send a link to people if people are interested in putting something on the document. It's a shared document, so if there's a good idea, I try to update it if people put conference opportunities in the Slack. I'll try to like update this file and we'll review it in the meetings. So the next thing, there's this ALife conference, ALife 23, and that's coming up. The deadline for submissions for that's coming up at the end of this month, beginning of next month. So this is Artificial Life. If you're not familiar, this is their 2023 conference. It will be in July in person and virtually. So it would be Sapporo, Japan if you want to go in person, but I don't know of any of us who will. So it would be virtual for us. Hokkaido University is the host university. So Japan has some interesting people in artificial life and artificial intelligence. A lot of groups there doing a lot of really interesting stuff. So if you go through to the link, and this is another situation where we're time zone asynchronous. Anything we would attend would be like at a weird time of day for people in North America, because they're 13 hours off of North America or so. So but that's the way virtual collaboration works. So the theme is Ghosts in the Machine, and it just it's they're looking for submissions. So that's the conference website. I have two ideas I want to submit by the end of the month. I've been working on the drafts of these. I'll be sharing them soon. One is on this open source ethics project, which I have sort of written up a preprint form. It'll be like the submissions for ALife is about 8 pages in their conference format. So it's going to be about 12 pages of regular text in the typical Times New Roman 12 margins format, single column. So this is the open source sustainability, and including like our a description, the introduction. Then I'm going through some of the things that we've done, models for collective behavior, reinforcement learning, and then this stuff on personality theory. I don't know where the heading is for that. Oh, here we go. So this is these are the 3 things that came out of last summer. I'm going to put them together in this paper as sort of interrelated models that we can use for this. And then I'd like to have some participation from some of the other people who are on the paper. I'm putting on the paper our 3 students from last year. Jesse, I think I'll put on the paper, and myself, and I don't know who else we want to put on the paper.
Please, I would like to be involved very, very much.
Oh yeah. I said the 3 people who were students last year, so you're one of
Cool.
those
Just
people.
making sure.
Yeah. So yeah, it's and your stuff is in here quite a bit, but I mean, I'm trying to present these models as things that we can kind of point in the common direction, just show the different approaches. This is what I like to call the adversarial approach to these kind of problems, because you get like a couple of people with different solutions to it. They work out the solutions, and then you see what you get, and sometimes it's a different point of view, but they all come together. They are kind of studying the same thing, so it's a good way to approach problems like this. And then this is an opportunity in the discussion to talk about something we couldn't talk about in the summer projects, which was the ethical regulator. And this idea of the Evergood regulator theorem is applied to ethical regulation. And then discussing a little bit about the sustainability auditing tool, which is Brian, of course, leading up that initiative. And I don't know if we need to include anyone from the project from last fall as an author. If they want to participate, they're welcome to. And so yeah, so that's that paper. Something in the chat. Oh yeah. Okay, I'll get to that in a minute. So the other paper is this critical periods paper, and this is so the open source ethics is for this ABM Hub workshop, and then the critical periods is for ALife, the main track, which is this paper here. This is something I'm working on. I'm not quite to the point where I can share it with people. I'm kind of synthesizing a lot of the stuff we've been doing, and then kind of, putting together some arguments and methods, and then we'll kind of move from there. So this is stuff that we've done before in previous contexts. I've been kind of building mathematical model of critical periods here, and then so there's some notes in here, but this is going to end up being like about 13 pages full, at the end. And so yeah, I mean, this is something that we've been working on this long-term idea of developmental neurosimulation, and we have a paper in the lab that is this paper here. It was published in Artificial Life Journal. This paper here, this was Stefan Dvoretsky, Z Gong, Ankit Gupta, who were all involved in GSOC several years ago, and then Jesse and myself. And so we're all on this paper, and this is using Bratenberg vehicles to look at developmental, like, embodied agents. And so the idea is you're using development as a way to look at a way to get learning, sort of bootstrap learning, building the agent's morphology and those changes included in that learning process and other things. So it's very much a little bit different perspective than what you get from the people who talk about AGI all the time, but don't really include the body or development. There are people, of course, working on development in artificial intelligence, and we're citing those people. And there's a lot of interesting work in that frontier. There are a lot of groups. Josh Tenenbaum, of course. What's his name? Pierre Odier from Paris. They're working on these different types of developmental approaches. And so, we're kind of throwing our hat in the ring in that. We call it developmental neurosimulation because we're not really building AI, we're simulating nervous systems, and we're doing this from the developmental perspective. So those are the papers I want to work on. Like I said, the deadline's sort of at the end of the month. I think they extend it by a week. So we have time. And I'll be posting when I get to a point where I think that they're collaboratable. Is that a word? I guess that's a word. I will share them and you can go through them. But yeah, if anyone wants to participate, if they want to contribute, feel free to come forward and say, I'd like to contribute. Brian, of course, is going to be on the open source sustainability paper, but I want him to go over it. I want some other people to go over it, and we'll get it in by the deadline. It's the way we usually work in the lab is we do a lot of collaborative papers and projects where we share them in the Slack, drafts of them, and then we put together the authorship based on, if the ideas come from someone or if they're putting in some effort into the draft. And, I'm pretty open on publication credit. So, yeah. So that's all we have in the immediate future for submissions.
Was NYCWiC on the list? Because that's
I
happening
didn't put that on there, or at least I think it is, but I didn't talk about it. Let's see. So what do we need to do for NYCWiC? We have the NYCWiC, which is the New York Celebration of Women in Computing, and this is it's actually not here. Here, 2023. And then we have this smorgasbord, or this, I guess, buffet on. This is the project where we have a number of things in this. So we have a collection of like 5-minute talks. Some of them are on, like, I think we were talking about the ethics of generative models. Some other things with law and policy. Yeah, so this is the key concepts in tech careers and tech ethics. So this is the thing that we have here. Okay, yeah, this is the abstract. I just need this part, I think. Oops. yeah, this is the part here, and I will.
This was the abstract that was basically accepted, and we're reducing it, although they haven't really followed up on was that it'll be eventually boiled down to 50 words version of it, but
Right.
basically it's currently we have around 20 minutes, and there's going to be 3 to 4 flash talks of around 5-minute length. One of them is going to be on one with sort of Ankit and Aiden with sort of GPT, I'm saying it wrong, and Dali, and all of those like generative and how that's affecting like creative stuff. One of them is going to be on open data and sort of the open data push, which is a little bit more like social or big changes people should be aware of. And then there's basically Brian's work and the ethical regulator work and some of the Google Summer of Code work put into what happened there. And I didn't know, well, the open source sustainability efforts. Ethical regulators was a slightly other topic, and I don't know if Brian wanted to put that in that or do a separate talk on that, or there's still room for another talk who want to make another flash talk. But the three are basically DALI and the generative AI. Number 2, open data and the push for open data from the NIH and others, and how do we deal with that? How do we deal with that? Sort of almost like policy analysis and sort of implications for that. And then the open source sustainability efforts that we've talked about. Those are all 3 flash talks, and anybody can join those if the newcomers want to join that, or the interns that aren't necessarily here right now in this meeting. And there may be room for another talk if we want to do it, but we can. Any of those topics could easily be 20 minutes on their own, so it's kind of just what people want to do. So, yeah.
Okay. Yeah, flash talk and ethical regulators. That would be good. That would be good. Yeah, I will prepare something. Maybe actually, what I'd like to do is kind of stitch these things together. Like maybe that's what I'll do instead of like a specific like so the sustainability project. The GSOC project this year is going to be mostly like maintaining that, what we did last year, getting that back, getting that like really kind of worked out. But there's a lot to kind of talk about, especially with respect to like how you would use this stuff and these ideas. And last year I gave a talk on just the general idea of open source sustainability, but this year I'd like to get like maybe connect that with like the generative models stuff too, because I think there's a connection there.
I would be up for you kind of reprising your role as like Lord Foreshadow of the Google Summer of Code project. So that's basically last year at this time, none of what we're calling open source sustainability project existed outside of, I think, Bradley talking about it on this proposal. Like, all right, well, what's that going to look like? What is that going to be? It made me want to do that stuff. So a year later, it's become a full-blown like active thing that has had people working on it. We've had a collaboration with the University of Albany to have people of very varying degrees of involvement work on like this sort of capstone project that turned into a website and make the project more accessible. So a lot of stuff has happened from there, and that's great. And there's the element of continuing that, and then Bradley, even if you want to kind of slip in like a couple of sentences about the VR stuff or other things, you can do that. Nobody's doesn't really matter. But I think that'd be a great thing for you to do, Bradley. I don't want to kind of say you should do that, but I think that's the most functional thing for you to do in some ways.
Yeah.
And you can kind of do the stitching and sort of that bridging there.
Yeah, well, I'm sort of the one who's kind of like managing it, I guess, like just from the 35,000 foot view or whatever. So yeah, I would like to. I would do that. I'll do that. I'll. When do we need to have these all together by? What's our timeline?
I mean, the real answer is the April, like the second week of April, basically. But I would like to have them done a little bit before that.
Yeah.
I also mentioned it to Erin, who may be involved or want to be involved too. But we discussed that, like, if she is, we'll be doing things a little bit differently than last time.
Yeah, yeah.
For those who weren't there, it kind of got rushed and changed and put back and whatever, and then she kind of phoned it in the last minute. So, but she made changes in that. Also, I don't know if I've mentioned her yet, but Jen, the public health person, she may try to. I think it would be good for her to have a little bit of like basic experience in she's not a technical person, but she's the kind of person who the conference would be great for in terms of someone getting used to engaging information presenting that way. So I think she may contribute a bit to the open data science, the open data and policy stuff. So more about that when it comes up. But there are a few other people who will be kind of doing cameos, or at least contributing to Flash Talks, even if they're not there. It's just they get some experience in that, which is kind of the point of that conference, is to be very, get people in engaged, initiated. So
yeah,
but that's it.
Yeah, okay. Well, let's stay on top of all these submissions and make sure that the deadlines are met. That's the important thing here when we do these. We have to meet the deadlines.
Yeah.
So
that's the thing where, like, I think that's the biggest thing as a meta commentary. I say this often, but when you're switching away from undergraduate research, where it's not just dictated by the whims of basically your PI, into like the research world and beyond, there's a it's sort of like you're managing all these deadlines, and you have to be aware of them and kind of bounce from them to the next one, and then occasionally you dip out. And I don't want to segue too hard here because I think we have a lot of things to talk about, but I do want to reference her a little bit. Like occasionally you dip out to do like some event where you speak, like Josh Tenenbaum did last night, and sort of like there's this academic science communication public relations endeavor that you do in the meantime, and that's a whole other topic. But I'll leave it at that and maybe come back to that a bit later.
Yeah, I'd like to do that. I'd like to talk now want to go over this week's. I've been doing this course on project management, and last couple of weeks I've been talking about working open, and I think that's pretty germane to what we do here. So if you look over the last few weeks, recordings from the last few weeks, you'll see like towards the first hour, I think there's some lectures on that, or I went over the lecture slides, in a pretty cursory manner, but they're there. Today I'm going to really kind of summarize like community building, which is Unit 2. So let me go to the slides here for Unit 2. We had 2 lectures this week. First one was sort of on the beginnings of, they had a quiz. The people doing the course in person had a quiz where they did some basic GitHub operations. That'll be in that repository if you want to check it out. So, open source community building, to have an open source community, which we talk about, it can do great things. It can build projects from scratch. But to have an open source community, you must first build an open project, then a community. And I guess what I mean by that is that you have to be intentional about what you want to do, what you want to build in the world, and then you build a community around that. You can sometimes bring together some people who are interested in something and build it. But if you don't have a plan forward, then it doesn't, it's not going to really do well. So like I said, most open source projects fail, but some are very successful. And I think the most successful ones have a certain intentionality to it. Like this, we're doing this thing. This is our set of goals. We're going to build a community around this. We're going to be inclusive, but we also want to keep an eye out for people with certain skills that can help us. So this is kind of going through the history of project management. I talked about this in the class. This is kind of that project management has been around for thousands of years. We've done things without computers, without even, our writing systems have been different or non-existent, and we've still done project management. So we don't have to do it all in GitHub. That's a very, very recent innovation. Or we don't have to do it all in like a Gantt chart. That's a more, been with us for about 70 or 80 years. But this is, project management of these large societal projects in the past, and they were managed, and we have these huge monuments, and the timescale for those were a lot different than most of the projects we work on. We work on projects that maybe have a time window of a couple months or a couple years. The pyramids took like maybe 100 years or so, or maybe more. They were multi-generational projects where you had to have you had to have a plan going forward. You knew that you wanted to build a pyramid. You had to recruit workers from different parts of Egypt, say, and you had to coordinate that over decades and decades until it was built. So, project management can be very long term. There are a lot of projects with respect to archival projects for seeds, plant seeds, and for data, old data formats that might otherwise go obsolete. Or even libraries are a good example of that sort of project management over a long period of time, where you have to keep things in a certain format or a certain set of procedures for many, many years. So this kind of goes through the history of project management, some of the different methods. And so I brought up this point about why do you want to build a community? And Adil Dash, who is a technologist, he runs something called Glitch, which is like an open source tool platform. And he talks about open source a lot and about technology. He has a quote here: "There are people making tech who are positive, ambitious, thoughtful, inclusive, curious, empathetic, and self-aware. They are going to win." This is obviously in response to a lot of the corporate tech, with a lot of the features that we don't like, surveillance or impersonality, or the problems with tech. He talks about community safety. He's pointing out that the one clear triumph of open source collaboration, the one that everyone knows has been the most successful, has really been the reporting of software bugs. If you release an open source project out into the world, you can report software bugs through a community of users and contributors, and it's much more effective than having like a centralized testing system where you test every eventuality and you put together a list of bugs and you fix them through a centralized project. So this is, but he's arguing that another triumph or another way that open source communities can be beneficial is by handling community safety, which is like keeping communities online safe from threats, from harassment, and other things. And so he has this blog post on this topic. I'm going to really kind of be brief about this, but I wanted to go into this idea of communities of practice, where you have a lot of open source communities coalesce around people who have a common set of problems or interest in a common topic, and they come together to fulfill these goals. So there are a lot of different communities of interest, and here you have all these digital companies or digital products that have emerged from these communities of practice. So like, for group discussions, you have email lists, Google Groups. For documents and knowledge, you have Dropbox, wikis, intranet. The point being is that you have these areas where people have interests, and then they build a project around it, and then they can build a community around it. And it's much more effective than just magically generating a community. So let's see. So this is just kind of going through building an open source community. I had a couple of points here on, you need to look at other communities that are similar to yours or interest groups similar to yours and get ideas of how to pull this off. You don't have to start from scratch. You also need a high-level engagement plan. You need to recruit community members. You need to have like an idea of who you want to see there. We do that with Google Summer of Code with the projects, but also with our internship programs. And we bring people in who have this interest in research and technology and open working and all that. And then you need to have people who are evangelists for the project, and you need to be consistent about promoting it. You need to get people involved. You need to get them excited about what's going on and tell other people. And so then you need to define the scope of your project. You need to kind of talk about some of the trade-offs in terms of usability and capabilities. You want to drill down on certain issues, or do you want to differentiate features in your project? Do you want, can you don't want to necessarily expand your community infinitely. You want to sort of work with the best group that you can find. And if that means you don't grow as a community in terms of members, that's fine. You want to be able to manage the growth. You don't want to grow quickly and infinitely. That's not the goal. And then you want to be able to prioritize things that are long-suffering issues. Like, if there's something that got abandoned 2 years ago, you want to maybe come back to it and start working on it again. And this is all things you can do in an open source community. There are all sorts of trade-offs. So if you prioritize one thing, you might have to give up something else. That leads into the second lecture, which was, of course, on picking up from there. So I kind of took a lot of the abstract ideas from the first lecture and said, okay, this is basically what an open source community is. You have this core set of project contributors, and then you have an open source community. Sometimes these things are separate. So sometimes you have like a core development team and then a community around that. And the community is sort of ancillary to the core contributors. The core contributors build the core of the project or the software or whatever it is. And then the community interacts with that. But they're pretty close in and they contribute actual things to the project. So, there can be a mix there in these two circles. But then you have this outside circle, which is the larger community. And this is where you might say recruit people into your open source community, or people who know nothing about your project or even the thing you're doing can enter your community through educational opportunities, through the evangelism route, or through just kind of casual interactions. And what you want to do is you want to keep engaged with the larger community so that you can grow your open source community, or at least sometimes you might want to build goodwill in the larger community for your project, your product, your project, so that you get more users or that you get more awareness, and that contributes to the health of your community and your core project contributors as well. So there are a lot of things that you can do here. This is how it's structured. But going back to trade-offs, then we talked about some of these constraints that you have on projects: cost, schedule, and scope, and sometimes quality. It can be conceptualized in different ways, but those trade-offs are always there, and you have to optimize them. So then I talked about kind of some of the aspects of community building, like building goodwill and building conversation channels. And there's this idea of social capital that comes into play, where you have to maintain a lot of social capital in your community. There's a virtuous cycle that comes into play. There's time management. There's, so you don't waste people's time. And then there's this idea of, people getting something out of the project as much as they put in. So people want to contribute, but you also want to give them opportunities or education or something in return. So this is like community onboarding. I've gone over sort of a checklist here of different things that you might want to do, that you can do is in terms of onboarding, and then cultivating community involvement, and then, giving some ideas of metrics, ways we can, at least with GitHub, automate some of these metrics so we know how our organization or community is doing. There are things like, starring GitHub repos and, communicating to the world what you're doing in terms of programming languages or topics of interest. And then, I gave a little talk on some project that I was involved in when I worked with the Rockwire Initiative. And this is a campus app. So this is for the University of Illinois Urbana-Champaign. And they have a campus app that is, that tells you things about the campus, information about all sorts of things. And one of the things that, you have on a university campus, especially a large one, is you have a lot of students who speak other languages other than English. So there's this problem where you have people who speak multiple languages. It's their first language. That's what maybe they're most comfortable with. What they can do with the app is they can switch to that language for a lot of the text in the app. screens. And so this is something that they do in software actually more generally, called localization, which is specializing that foreign language translation for specific populations and making it like more personal and more authentic than just a machine translation, because machine translations are sometimes pretty bad. So went through, this is a presentation they gave in the translation studies department, and I'm kind of summarizing what they did. They worked from a third-party plugin to GitHub called Crowdin, which allows you to manage a lot of the translations, make translations, and then there's an automated tool that allows you to apply it to different strings of text. So they're working with a lot of text data. They're working with a master glossary, and then incorporating new terms as they change, because with open source projects, there's continual change in the different text strings, and then getting all that in line, and then something that you can just hit a button and it flips to that thing. So this is all stuff that was done in this project. And I think this shows how an open source community can do this sort of thing and put this in a, sort of organize this in a way that is useful to the larger community of users, that's useful to the core development team, and so forth. So that's all we talked about for you for this week in community building. Next week we'll have more to say about it, and then we move to Unit 3 after that. So, all right, so let's see. We had some action in the chat. We had, there's a Notion document for the meeting. So if you open up this link that Jesse put into the Notion document, these are the notes that we're taking on different things. Okay, so feel free to add to that if you want. And then I saved Amanda's EI proposal. They're also okay. Yeah, and then Vrushali wanted access to the document, I think. And then yeah, Raj also. And then yeah, so please add to that if you have ideas for things. I mean, we just put notes in there and they're pretty unstructured. Jesse tries to structure them a little bit more when people put them in, but don't want to exclude people's ideas. They're reasonable. It's like something nonsensical, then I mean, not nonsensical that we don't understand, just but yeah, so that's all I had for the update on the project management course. I've been trying to do this like sort of asynchronously in the Discord. I know we've talked about this in the past, but I've just been putting the notes in there for now. We might do some more discussion about this once we get some critical mass in the lectures, because this is the first time doing the course. I'm just kind of designing the slides from scratch. And this is, but we want to like continue this on. I think this has a lot of use for people. I think it's a lot of utility, because I have not seen another course like this where you're teaching open source, you're teaching project management, and then there's this middle ground where you have a lot, it's even cognitive science like in a lot of ways. So okay, do we have any questions before we move on? All right, Jesse, I was wondering if you wanted to give a short talk about what you've been doing at AAAI this week.
Yeah. Let's see if I can come on for this. I don't know, my wireless was a little strange. Basically, it's been a very interesting time, because for those who were there, Wednesday night was my first night here, and the Wednesday night was just kind of a mess, because I think it took me 5 hours. I was waiting for dinner for 5 hours because I ordered 2 deliveries, just disappeared into the ether. My room service was late. I don't ever order a room service, but it was late for an hour, over an hour, like 80 minutes late. I had to call them and like, what happened? So needless to say, that was very strange and unpleasant. And the first like 24 hours were kind of a mess. We had the condition futures reading group that night, which is really good. Highlight of the day. And then there was sort of Thursday and Friday. I'm kind of finding it's tough because I am not, a lot of the stuff that so far have been happening is really specific technical sessions. And it's kind of been, okay, well, I know a little bit about this or that. So I haven't gone to a lot of things in person, but I have a lot of access to really high quality papers and direct connection to the authors. So what I'm doing is, like for plot twisters and also for some things here, I'm kind of just scouting. And my day job, I'm scouting to find papers and authors and specific things that will basically help our many projects. And that's been good. Plot twisters is looking at a lot of things in natural language processing, some sentiment analysis, some things that will kind of are about conversation and stuff like that. And we've kind of picked out a few of those things. And for work, it's some things about biometric and other like kind of some mostly computer vision stuff, because like this is basically a machine learning conference. It's not it's mostly just straight up research too. Like the applications are kind of limited, so it's maybe not really a true conference for most of my interests, but at the same time, Josh Tenenbaum was here Friday night, and that's kind of the highlight of it for me. I'm sorry, I keep getting this pop up on Gisty encouraging me to use this other thing because I'm connected. But I'll say more about Josh in a minute. But the rest of my time here, workshops are going to be Monday and Tuesday. I'm going to be at like a health intelligence workshop most of that time, because that's going to be the biggest. That's kind of the main reason why I'm here, because I have to try to glean some information that can be useful for other things I'm doing. There hasn't been a lot on. There's been hardly anything on virtual works in a reality here, which makes sense. But I was hoping to find a little more on that. But there's been some good like diversity efforts and things like that too. But mostly it's kind of, there's a lot this morning that I wanted to do, but I was pretty exhausted, so I didn't do a whole lot. I'm going to go back to it, but it's very useful for highlighting some specific advances in the field. You can get papers, you can get slides, you can talk to the authors, and that's kind of, I'm basically using it as a enhanced networking opportunity in that sense. Oh, I can share my screen and kind of walk you through Notion a little bit. I probably can help a little bit. I've taken some things, some notes here. For those who don't know, or I don't think I gave. I keep forgetting how to say. The person I just gave access to, I didn't give you full access, so you won't be able to see this, but I'll give you that in a little bit. It was just for the discussion, but kind of the main hub is the library and our meeting notes page. This is basically all of our meetings in order. So SMM and Saturday morning NeuroSim. Library breaks down into meeting notes. Library is kind of the big meta dashboard, if you will. Reference materials are for like books or papers, people, outputs, and then events. And that should probably be up here. So this event is AAAI, Association for the Advancement of Artificial Intelligence, and I've been kind of collecting what I can here. Like these are some of the sessions that seem somewhat interesting. There's some NLP stuff. Where did this one come? This was actually a really good talk. I've read a few notes about it. But I wanted to come back to this one. I think this was in. Yeah, I kind of just took a screenshot of a bunch of the sessions because there is really a great way to organize them, and I understand how they're trying to just put some organization to it to the main website. But I mean, just to show you kind of, oh, it's not gonna work. Like I'm not even gonna show you the website because it's just such a mess trying to sort out the schedule. Like it's like a calendar that's triple booked. Like you can have triple double booked that are overlap, but it's like 35 booked, and it's just so impossible to tell. Right? Like scrolling through it and just figuring out stuff. I think at this point, because in the interest of time, I'm just going to talk a little bit about Josh Tenenbaum because it's quite related to a lot of the stuff we're doing in the cognition future sense, both in his take on probabilistic programming, in the sense of his diplomacy and his science communication, and finally his framing. And I don't think I have all the stuff in here, but maybe I can quickly put them in there on my phone as need be. But his framing of how do we get better at the cognitive science project, which I really, as a I've said some things in the Slack here, like I think it was here. Yeah, like as a quick summary of it, I would say I was really impressed by his diplomacy. And you can let's go back to this whole thread. Well, can I go back here? I think I've seen more out of all the people's talks I've seen over the course of my like academic career and history. I think Josh Tenenbaum is the person I've seen talk the most, which is kind of ironic because I haven't done a lot in probabilistic programming in the way that he's using it. So that's something I want to change this year. But seeing his communication over many different audiences and subtopics and what he's trying to do in those different spaces has been very, very interesting. And I have a lot of respect. It's almost like he's kind of doing a certain kind of advocacy work because I realize now that he's kind of in this unique position of at MIT, and MIT is like the engineering school, or it'd be computationally rigorous, technically rigorous. Like you have to do it there. But he's this guy who's like, he's not. I don't see him as a hardcore cognitivist, computationalist centered person. Even that's what he's doing, but I feel like he's not. Even though he's I think I have a I guess different layer of respect for him now in the sense of what he's trying to do. In that, it's almost like he's doing a specific kind of advocacy work, and you can kind of see some things here, but
See a physics of AI slide. That's interesting.
I don't know if that's his or not though.
Okay.
I don't think that's his. This was whose was this? Was this the first night? Yeah, this was the Thursday night keynote. This was no. I don't know what that is, but basically the Thursday night keynote. Oh yeah, okay, I know. It's did I put it in here? Let's see. Yeah. Well, I don't have any notes here, but it was basically the Thursday night keynote was basically saying, it was smacked a little bit of physics envy, but it was sort of adjacent to what Josh was getting at. But for the sake of my fragmented nature right now, I'll just get into Josh's talk, and he basically he did a lot of the first like third of the talk was him realizing, okay, I'm in, I wouldn't say hostile territory, but like I'm in the midst of deep learning land and machine learning land. And he was saying he basically spent almost half the time, I would say, but a third of the time kind of getting to the place of neural networks are important, machine learning is important, they do a lot of stuff. Here's how they do it. They build they do a lot of really good work, and they do data modeling, and their job is to do data modeling, and that's great. That's given us XYZ things, and that's great. So he's kind of doing a diplomatic work of saying, hey, you guys are important, we need you, and this is great. But I want to suggest we do more than that by saying, well, we also basically get world modeling and other ways of things that aren't just modeling the data and having these sort of bigger, broader cognitive paradigms and mechanisms at play. And so he's kind of saying, let's start with that. That's great. Let's talk about this. This is where we want to go, and other stuff like that. And he goes back to this later with, intelligence isn't just about modeling data; it's about modeling the world and sort of the transition over time. And he said he started with the common sense core and kind of getting at like intuitive physics and sort of developmental related stuff. Yeah. So I'm just going to go back to this because I think most of what I did is on my phone and I don't have it ready to share, but he eventually leads up to probabilistic programming and kind of mentions probabilistic programming as a kind of a nice view of bringing in symbolic languages, probabilistic models, neural networks, and all of these different things together and making it into something that can be do the kind of probabilistic and generative work, if you will, that he is seeing as a potential solution, or a path forward that needs more development. I don't know, is that Brian? Yeah, I thought maybe Brian just laughed at this, but it was very, for those, I'm not doing a great job of presenting his views and more commenting on how I presented them in this recap, but I do think it was quite interesting that one of the questions at the end of his one of his questions at the end that he received at the end of his talk was, "Oh, this is great," because he kind of very slightly alluded at embodiment, and he very lightly alluded at, yeah, the work being done in developmental psychology. Maybe I can find that slide. There's a slide that kind of summarizes his views at the end, which is basically saying the work being done in like the developmental psychology, some biological stuff, is getting us to the place where we can getting towards benchmarks that we can get data around, test and build models, and do the cycle of benchmarks, data testing, and building out these better benchmarks and better models and the virtual cycle of that. He's like, that's what we want to do. And he's basically saying, yeah, I think we're finally making progress in the developmental area, nudge, nudge, without, and he was almost under his breath about it because he doesn't want to do it. And it was funny because one of his questions was basically, yeah, I'll put this, I don't know how I'll do a quick like share to my thing as this is coming through. One of the questions was like, this is a great talk. But it was a younger person who probably hasn't been to like as most like an AAAI, like a machine learning person. It's like, but I think you're missing something. I think you're missing like, millions of years of evolutionary development in this talk. And Josh's reaction was pretty funny because he was like, "Oh, that's great. That's kind of the whole point of my talk."
Yeah.
And I'm a little bit sad he didn't get it, but that's the whole point of my talk. Is he did, without saying it, his point of his talk is like, yeah, there's this evolutionary development that's happening, and what we're trying to do is like simulate it. We're trying to basically recreate the development process in these computational simulations and go through the process again, because we can't, like, how do you make up for that? And that was the point of his process. So it was kind of funny, but also like, I feel like he really I was impressed by his, because there's sort of the technical talk that you're giving, and he explained really well, and he's good at that. There's also like the advocacy work you're doing, because the main purpose in being there is yes to put on the CV and represent MIT and represent your program, like yes, but also like if you can convert some people who are hardcore into the machine learning camp to come over and say, oh, we should maybe give some time to this, and I feel like he did that. It was almost like a legitimate hidden agenda of like, I want to talk about this stuff, but I want to seem credible. And if you want to help us out in this area, we need it. It was kind of like strategically well done. So
yeah,
I was impressed by that.
Yeah, I think there's a lot to explore. I mean, it's not the mainstream approach. So always had the impression AAAI was more like kind of more diverse than say like NeuroIPS, which is like to say it wasn't as machine learning oriented, or is it mostly machine learning now?
It's tough. I'm probably not giving it the fairest of shakes right now because of my particular situation relevant to everything. And I'm gonna pull up. Oh, it's not gonna let me do that, is it? Do it the old-fashioned way. I'll take a screen because when Apple sends stuff, it does that weird HECIC format.
Oh,
and
yeah.
It won't let you.
Oh, he froze up. Oh, there it is. Screen share. But it's blank. I don't know. Yeah, I don't know. So Raj, thank you for attending the meeting. Yeah, we'll keep in touch on Slack on that. Yeah, you're back. Okay.
But it feels. I don't know. Maybe it's just that I'm not manipulating the schedule well, but it feels like a lot of the stuff was kind of pushed into one zone. So I don't know. I feel like NeuroIPS had a little bit more actually in the way of just like we're gonna have a workshop on the cognitive science stuff, and there wasn't one this time. It felt like there were some other workshops, and well, the workshops are at the end of the event, so I don't know yet, and I can't really go to many of them. But it felt a little bit more. I don't know. Maybe not as much as I think NeuroIPS was a little bit more diverse in the array of like cognitive stuff, perhaps, but I don't know. But it's basically conclusive. Can you see the slide that I'm sharing?
No. That's okay. I think you went offline when you did that before. So why don't we just, I want to move on. Well, you can just show it quickly, I guess. Now it's working. Okay, there we go.
It was just, and he was getting at these things and sort of the work in intuitive physics, psychology, and the developmental stuff as these are the way forward, and how do we get models and work towards benchmarks and data to test them and better improve the models and stuff like that. And these are kind of the ways he's seeing that. So the end.
Okay. Well, thank you for sharing that. Yeah. So that's great. And yeah, maybe next week we can talk more about it as you, obviously this is a very long conference, so we'll talk more about it. But thank you for the update. Okay, I wanted to finish up here with talking about something we were doing last week. So last week we were talking about this debate that's kind of emerged from this paper, the Weisman-Feldman-Barrett paper on cognition and like how cognitive neuroscience is focused on sort of brain localization tasks in controlled experiments that activate certain regions. And then this is counter to the view that the brain is a system, that it's a wide-ranging, naturalistic type of interaction with the world. So the brain, to do experiments where we can measure what's going on in the brain using the former methods is totally inadequate. We need to have a new sort of perspective on how to measure things in the brain. Now, we've been talking about this a lot in Cognition Futures, and in last week's meeting, I don't remember, I queued it up. I sent a message to Hussain in the Slack where I queued up the time point in last week's meeting where we had this, and I think it was in the Cognition Futures channel. So yeah, I was here last week's meeting. I can't remember what the exact time point is, 4032, where we talk about this. And this actually comes from this paper that we talked about last week. So there were these three assumptions that are made typically in cognitive neuroscience, where the localization assumption, the one-to-one assumption, and the independence assumption. And then they're giving alternate interpretations of that, or alternate ways of viewing those two sorts of things. So they're interested, instead of specific regions, they're interested in neural ensembles, which are diverse, which are sort of transient, but you can measure them. And this is in contrast to just single areas being active. Then there's this one-to-one assumption, which means that neural ensembles may or may not map uniquely to certain psychological categories. And then the independence assumption, which is the dedicated neural ensemble functions independently of context. So we know from a lot of the stuff we've done with in the cognition futures group that context is a big deal, especially like if you're doing something in the world and you measure it using a naturalistic approach, or if you measure it using, if you measure it from, beginning to end of the process, instead of just having a controlled experiment where you present a stimulus and you do a number of trials and average over those trials, there's going to be a lot of individual variation and so forth. So that brings me to this week, which is an update on this topic. And I found some things. Actually, there's another thing I wanted to present, but I don't think we're going to have time for that. So there are a couple of things. Actually, that's not what I want here. This is actually a tweet from Johan John. So there's this is morphed into what they're calling the modularity debate. I've learned a lot from this modularity debate. When you dig a bit, you find a great deal of nuance. For example, this artificial neural networks paper points out the indirect measures of modularity, which is this idea that there are specific modules in the brain that do specific things. So modularity is where it's just functionally segregated and functionally in parts. Often mislead us about the existence of functional modules. So this is something in artificial neural networks where this is a paper from the archive. This is the link to the paper. Our new method for inspecting modularity in neural networks is the first to identify modules by their functionality, making it easy to interpret what neural networks really do. Unfortunately, it shows that in typical current neural networks, weight sharing between modules responsible for solving certain tasks does not really reflect task similarity as desired, but can mostly be explained by rather trivial shared input-output interfaces of solution implementing modules. In other words, what that means is that if I say that I'm doing a task, and then a neural network, so this is different than the brain, but this is actually instructive. If a neural network can solve a certain task, I can go look at that neural network and I can look at the activation patterns. But the thing is I can't define the tasks by the activation patterns. The activation patterns might be the same for different tasks. So we can't really divide those into modules. We can't say that this is the recipe for this task. We can only let the thing run and come up with a solution, and that solution might be shared across tasks. What actually is going on, though, the way you can explain this, is that there are these shared input-output interfaces and solutions to certain problems that are sort of shared. So, in other words, instead of it being something to do with the task itself, it's really the way it comes to the solution, the resources it uses to arrive at the solution. So this is actually instructive for the brain because that suggests that the brain is just kind of working on things independent of our categories of them, or what we think the brain is doing, and it's just coming up with the activation pattern. This is Nancy Kanwisher, who had some disagreements with Feldman Barrett, and this is actually Russ Poldrack, who's another cognitive neuroscientist. He said the recent modular versus distributed debate seems so 20th or even 19th century to me. The science of complex systems has taught us that a system can be both modular and interactive. It's like arguing over whether stars or galaxies are the right astronomical unit to study. And Nancy says, exactly. As I said yesterday, the brain affords many levels of analysis, from molecules to neurons, to circuits to brain regions, to brain-wide networks. And none of these levels obviates or explains away any of the others. So this is one view of this. There's another view here. This is the one I want, which is embodied in this Nautilus article. And I guess it's sort of related to that. It was a comment on that last post that I showed. But this is an article from, it's on physics. And this is, I think I've talked about this before. This goes back to this idea of universality that Brian was talking about, that we've talked about in past meetings, about how systems have this universal property where if you look at, like, you can look at this universal property in a number of systems that are maybe related, but maybe not obviously. So in other words, if we look at universes and we look at the brain, they don't obviously seem to be connected, but we can actually say they are in terms of their structure and their dynamics. But we have to take a very broad view in something they call universality. So this is a strange similarity of neurons in galaxy networks. Your life's memories could in principle be stored in the universe's structure, which is a cute way of saying that those two systems share structure. So Christoph Koch, who started out as a physicist and now studies consciousness, he's talking about some of these things, is kind of pointing to this similarity in the article. And then, so this is we being these two authors, Franco Vazza and Alberto Folletti. So we, an astrophysicist and a neuroscientist, joined forces to quantitatively compare the complexity of galaxy networks and neuronal networks. The first results from our comparison are truly surprising. Not only are the complexities of the brain and the cosmic web actually similar, but so are their structures. The universe may be self-similar across scales that differ in size by a factor of billion, which is very large. So the size scale is very different, but the structure is basically, they're arguing the same. And so what they do in this, so this is 27 orders of magnitude larger than the human brain. And so how do we know that they share structure? So I'm trying to get to the payoff here. Okay, so this is what they do. So I know we've seen this, and I explained this several meetings ago, but this is something they call a power law distribution, and they use this a lot in physics to describe these kind of structural differences in systems. So when you have a system that is organized hierarchically or that has some structure that's meaningful, you can compare the structure of different types of systems in this way. So like we've looked at that in terms of networks, in terms of hubs, the degrees of hubs, meaning how connected are hubs relative to peripheral nodes. And we can come up with a calculation of their centrality, of other properties. And we can actually compare across networks. So we can have a social network, a technological network, a brain network, and they all have this, we can all put them on the same scale of comparison. So really, statistically, it's just a matter of comparing the statistics of those networks. So that's kind of what they're doing here. They're actually looking at the amplitude of fluctuation within scales. So, and then they're looking at the spatial frequency. So they're not actually looking at the network statistics here. They're looking at some spatial frequency, which is, the amplitude of fluctuation. And they're actually looking at the cortex, which is one part of the brain, the cerebellum, which is another part of the brain, and the cosmic web. So you have two parts of the brain that are organized differently, and then the cosmic web, which is a network, but they're not measuring actual network statistics. They're doing this in a little bit different way. And what you see is this similarity. You see that they start with this log. This is a log plot, I believe. So you have these values for amplitude versus spatial frequency, and you can see that they track pretty well, and they form this power law. You can see a little bit of the curve on this log scale, but if it were like a linear scale, it would start at the top here and then go down and have what they call long tail. And so this is the statistical signature. And then for purposes of comparison, they put in clouds, tree branches, plasma turbulence, and water turbulence, which are just like controls to show that it's different from, say, non-living systems, or I guess the cosmic web isn't really living, but it's different from these kind of systems that are, actually tree branches are living, I guess. But the point being is that they're different from different types of systems. So you can't say that, okay, these two systems are similar, but every system behaves this way. That's not true. This is their sort of how these things are structured, and yeah, so that's their argument for sort of thinking about the brain in a different way than this sort of modularity, or maybe there's modularity in this. But this is an interesting paper. I can share this folder later. And then this brings us back to this paper by Varela from 2001. I put this in the bibliography for the Cognition Futures project. But this is the paper that Varela wrote in 2001 on the brainweb, phase synchronization and large-scale integration. So he makes the wholehearted case for brains as systems, as distributed networks. And so he's actually making this argument for the coordination of scattered mosaics of functionally specialized brain regions. So he's saying that they're specialized brain regions, but that they get activated in this mosaic pattern, that they get coordinated, and that's how we get our cognition, not through like specific regions that are light up, and that there's a one-to-one mapping between the behavior and that brain region. And so this is like 2001. So this is actually before a lot of the work on the modern work on brain networks came into being. So this is kind of almost like aspirational in the sense that it's has a lot of these. It lays out lays down the groundwork for this sort of systems perspective before we really had the data in place to like test this. So it's really interesting because we're making the same arguments now. We have data for this, but this is where it comes from. So although the mechanisms involved in large-scale integration are still largely unknown, we argue that the most plausible candidate is the formation of dynamic links mediated by synchrony over multiple frequency bands. And so this last part, I talked about Walter Freeman, I think in the Cognition Futures group. He talked a lot about synchrony and the EEG bands, which are, of course, these frequency bands of activity, these local field potentials that become manifest in different frequency bands. And that's one of his arguments for like sort of the complexity of the brain. There's also this idea of brain networks, which are where you look at the brain during a task and you see these different areas and you draw inferences through like a correlation matrix as to how they're connected at any one point in time. So we have these tools that are in place that people have introduced over the years, and Varela kind of put this together, and this was before kind of we had the data fully connected. So I mean, this is something that this is the point of view, for Feldman Barrett's point of view on this. They actually have a section in here. They draw analogies of different types of networks. So they talk about the World Wide Web, and this is great. A useful analogy is found in the World Wide Web systems such as Napster, which dates the paper, but still.
Wow, I haven't heard that in a very long time.
Yeah, Napster reference. Okay, so this is from 2001, and they go through phase synchrony and some of these other ideas of neural assemblies. And again, this is before they really had the data in place, but they did develop some mathematical models, phase and synchrony. So it's these networks, but also synchronized in time. That's how we get cognition, and it's a very different view than like the traditional cognitive neuroscience view. But as I've pointed out in some of these other papers or some of these other posts, there's this very, very enlightening debate, I think, going on. And like with these Twitter debates, they kind of fly in different directions, so it's kind of hard to track. Finally, this is another paper. This is Tononi, Sporns, and Edelman. These are all pretty big names in neuroscience. And this is PNAS from 1994, a measure for brain complexity relating functional segregation and integration in the nervous system. So even as far back as 1994, people were thinking about this debate and how these things could be measured and how this relates to brain complexity. So there are other papers on brain complexity I'm not going to go into, but I just wanted to leave that there for people. This is kind of like this ongoing debate, and it'll be going on for a long time, I think. We're not going to solve it anytime soon, but I wanted to go back. And Brian had to leave. Thank you, Brian, for attending. Okay, so I think that's it for today. Did we have any questions before we go or comments?
I would just ask, please, to share those papers because I want to. I didn't really get the most out of this meeting because I have so much stuff going on, but I want to review everything, particularly those papers in that debate. I think that debate will be. I think I want to definitely. I don't know. Within the Cognition Futures project in general, or the Methods project, I think that's a really important debate to just like.
Yeah.
I think we should basically write up something internally.
Yeah.
To do it, but also like maybe a blog post about it for externally too. But yeah.
Yeah.
You gonna say something, Amanda?
Yeah, I was also gonna say I would love to if you could share the papers. Neat find with the Varela on these like those different measures. Complexity and coherence and some of these other things are measures that I'm learning how to work with in my research assistant job, like learning how to put it into practice. So I'd be very interested in what Varela has to say. I think it's interesting.
Yeah.
I don't know, I guess just like the technological and theoretical advances in computational neuroscience and data science, if those could be more inspired by this maybe philosophy that came before them, that could be interesting. Like how could these tools that have kind of developed in the industry of science, like what gets the results, how could these tools be modified and expanded on based on more like philosophical concerns, I guess.
Yeah.
Well, I think without getting too far into it at this point, I think that's sort of a common link between even some of the Josh Tenenbaum stuff and Brian stuff and this stuff is that. And I think part of like learning how to talk about that and make that explicit is part of like the Cognition Futures project too. So yeah. Anyway, I have to go myself. So
all right. Well, thanks for meeting, and we'll keep the conversation up in the Slack. Yeah, thank you, Vrushali, for attending.
Yeah, sticking through. You don't have to stay the whole 2 hours, by the way, but 2.5. But it's great that you did. So thank you for that.
Yeah, thank you.
Or use Slack with any questions you might have.
Yeah. All right. Have a good week.
You too.
Bye.
Bye.